What's up, guys and gals? Welcome back to the Corridor Digital Podcast. Since you guys are the Croutons, the truest of the Croutons in watching and participating in this podcast, I wanted to let you know that the merch store has been restocked. That's right. Before we even start this episode, if you missed out on the emergency green screen blanket, if you missed out on the mocap crew neck, if you missed out on the joggers or the backpack or a couple of the other really awesome items that we dropped late last year, well, guess what? They're back in store right now. So go on over to corridordigital.store and check those out. And let's get on with this podcast. That's right. We're going to talk about AI today. And this is a little bit of a precursor to a couple other conversations we're going to have here, where I think the topic of AI superhuman governments is going to be hotly debated. So stick around and find out how robots are going to take all of our jobs. Third week in a row to the Corridor Cast. You might notice that we're wearing some of the same clothes from the previous episode. Well,
you know what? Since we were just talking about goal setting, I think this consistency that we have to the podcast is going to help us reach our goal of actually having a real podcast.
Our goal is to release, so this is great, actually. Our goal was to release a podcast once a week this year. So far, we're 3 weeks in. We've met that goal every week.
Heck yeah. No, we just got to keep it up, right?
Yeah.
Consistency. Keep
But
running
that's why
with
we're
it.
recording
Keep it
2
up.
episodes here together so that we can hit that goal.
What's our topic today?
All right, ready? Before we start the topic, timer starts now. We've got 30 minutes. Niko wanted to talk about machine learning and what he's learned about the machines learning.
Yeah, more commonly known as artificial intelligence.
Yes.
Well, are we talking like calculators here? Like that memory button? Is this what we're talking
Are we
about?
talking calculators here? What is a computer? Tell me about it.
A computer?
So what is a calculator? Just a big brain in a tiny little box? No. Wait, so what's my actual prompt? That wasn't a real prompt.
Your prompt is I asked you if you want to do a podcast, and you said, yeah, I've been discovering a lot of things about machine learning and AI. I'd love to talk about those on the podcast. And then I said, that sounds like a fun topic. Why don't we do that?
Okay, cool. So machine learning, what is it first and foremost? Basically, machine learning is a way for a computer to learn something on its own. And what I mean by that is, like, let's say you have a problem that you want to solve and you're going to have the computer solve it. Let's go with a simple one. Green screen, right? Okay. So you want the computer to take everything green and make it transparent. Now, in the past, how you'd usually do something like that is you'd go in and you would set the rules. You would say, okay, everything that has this value of green in its pixel, give it this much transparency. And maybe I'll expose some like controls to the user. So like they can change how much transparency per green and how much tolerance I have into like the blues and the yellows and things like that. But you're solving the problem as the programmer. You're saying, okay, here's the math. I'm doing the formula. Here's the math. Machine learning, on the other hand, all that is abstracted. You just give it a start point and an end point, and the computer figures out everything in between. And it's all one big mess of interconnected neurons, and you don't really know what any of them mean or what any of them do. You can't just like tweak them yourself afterwards. The computer basically just writes its own program internally to achieve the end result that you want. And the thing is, this is very similar to how our brains function with how our neurons work. And so machine learning ends up having a lot of analogs to like our pattern recognition process and all these other like thinking processes and visual processes that we have. And it's like, you know, if you've seen like Google Deep Dream, for example, where they, you know, everything starts looking like dogs everywhere. It's doing basically pattern recognition and then matching that pattern to other pictures. And that's similar to how we see things. Like you'll see something and you try to recognize a pattern and apply that to other things that you know. Like, okay, a face, 2 dots, eyes, 1 dot, maybe a nose, line, mouth. Okay, I got it. It's a face. You can recognize that pattern. I could do a whole series of dots and lines, and you could pick out all the smiley faces in it. Whereas if you were to show that just to a camera, the camera doesn't see anything. But if you went in and did like machine learning, you know, you could train the computer to recognize faces, and in turn, just like how you can recognize those patterns, a computer will work out the similar way. The reason I've been so into machine learning is
Wait. Sorry. Yeah, keep going. I have a question when you're done.
Okay, the reason I've been so into machine learning recently is, you know, as you guys know, I was doing a lot of deep faking stuff during the summer and fall last year. And it's not actually that hard to do machine learning, like to sit down and code something and like have a computer like then chug and like calculate a way to like figure out a problem for you. It can get very advanced and complicated, but not like starting out, it necessarily isn't. It's actually very approachable because, like I said, kind of the beauty of it, and this is a bit of an oversimplification, is you can kind of just give it your end result, and the computer will figure out how to get there. Like let's say you want to colorize black and white footage, and you want a computer to do that for you. Rather than trying to go in and like manually say like, okay, anything that looks like a tree, make it green. Anything that looks like the sky, make it blue. Like you're not going to go in and do any of that. Instead, what you would feed the computer is you would feed it black and white images, and then you would have what's kind of called a ground truth. And this is for a certain type of machine learning. There's different types, but let's say you go out, you film with your camera outdoors, right? You have the color images. It's on your camera. So what you can do is you can give the computer the black and white image. You can say, hey, try to colorize it. It'll try to colorize it. And you show it the actual colorized image. You say, how close did you get to the actual ground truth, what I wanted you to get? And the computer can look at that and be like, oh, I did a really bad job. The sky is orange. Or, hey, the sky is blue and it's supposed to be blue. Okay, that one, I did better there. And by repeating that process over and over, the computer hones in on some weird neural network that gets it to spit out results as close to the ground truth as possible. So you no longer have to go in and figure out what math to type. The computer figures it out because all you have to do is give the computer the end result, the right answer, and then the computer will go through and make its own guess and see how close to the right answer it was, and then it'll repeat that billions of times until it hones itself down to get the right answer as much as possible.
So is that the same thing as like chess? When, you know, the computer can be chess masters or Go masters?
I mean, a little bit. You can get a little bit in there, but no, because chess already has the rules. So you're actually already programming in the rules. There's not necessarily rules to machine learning. You can start adding some of that to the thing, like hints and, you know, boundaries and things like that to help contain, you know, the computer. Like when I do a deep fake, it goes through another thing first that marks landmarks in the face, like where the eyes are, the nose, and the mouth. It doesn't just look like a blob of pixels and try to guess where the face is. That step's actually already kind of done. So it has hints to where the eyes and the nose and the mouth is and where the general boundaries of the faces are, to help guide it to get a more accurate result. Otherwise, you can kind of end up in the ether of the computer trying to solve a problem without any guidance, and it, you know, sometimes gets bogged down. But, you know, a chessboard has rules to it, and it has a certain state that it ends in that you can mathematically define really easily. And so that's much more of a, you know, this piece can only move like this. This piece can only move like this. Do a tree of decisions as far as you can go and figure out which one gives you the best result. And like, what is the best result? Well, capturing more pieces, capturing more territories. That's up to you as the programmer to decide. And then you can balance that. And like, in a way, there's a little bit of machine learning you can do in making those kind of things. And by, say, making a bunch of different types of programs and then having different weights and the influences of like, how important is it to capture pieces versus how important is it to capture territory? You can have a computer try different variations of that off of itself and see which one leads to optimal results. And that's, in a way, a sense of machine learning, but that's not the kind of machine learning I'm talking about here.
Yeah, theoretically, with like a chess game, too, you can basically say, all right, we're literally just going to calculate every single possible configuration of pieces that could ever go on this board. Mm-hmm. And then when you're doing a game against an opponent, basically each time it hits, it's basically hitting a fork in the road going, all right, well, there's more win potentials down here, so I'm just going to move because I've already figured out all the potential moves on a chessboard.
Yeah,
that makes sense.
So the tricky thing about chess is that you can't calculate all the potential moves because there's too many. It's like the number of potential moves from the beginning of a game of chess is like more than there are atoms in the universe. You can calculate out to like 7 or 8 moves down for all the possibilities, and then it's
oh really?
It's like, yeah, then it's too much to figure out.
Well, shows how much I know, I guess.
Well, it's the right start, but then you want to go like, okay, so what state do I want to kind of get into? That's ideal, and then from there I'll do a new tree once we get to that point, you know.
We've made a lot of assumptions going into this conversation that I need clarity on.
Okay. I haven't even gotten to why I'm really into it yet, by the way.
I know. We'll get to that. You started this conversation by saying machine learning is what occurs when a computer teaches itself something. So let's just boil that phrase down for a second. At what point, because a computer originally, you know, actually was a computer. I mean, it still is, but it's just like 2 + 2 = 4. So at what point does a machine, a computer, learn something on its own? Where does that occur? Because hasn't that already occurred up to this point?
It has, and arguably, like, computers can be learning in a lot of different ways. The thing that makes machine learning special is the computer's figuring out the solution on how to get to that solution on its own. Like, there's a lot of different ways you can train a computer and you can have a computer do work for you, but machine learning is special in that you're not the one going in, typing in the code that says, okay, run these tests to solve the problem. The computer figures out internally what tests to run to solve the problem.
So at some point, some human went in, and was like, okay, normal computer function does this. You give it a series of parameters, it tries to solve the problem, and when it can't solve it, it just stops. So then somebody went in and was like, program to go back to the start and then a variable.
Basically, like, you know, the monkeys and typewriters scenario. Given an infinite amount of monkeys and an infinite amount of typewriters, eventually one monkey will type all the works of Shakespeare.
Sure.
Yeah. Have you not heard of that before?
Yeah. Well, I've heard that in different analogies, but yeah.
I mean, basically, the idea is that if you are randomly generating letters, right? At some point, your random assortment of letters, if you have infinity time and infinity possibilities,
and
eventually those
monkeys.
will be in an organized state where they happen to be arranged in the same way as, you know, a play of Shakespeare.
Is that how hacking passwords works?
I mean, it can be when you brute force it, when you're just literally going through all possible combinations.
Okay, so at some point, so we get to bring me up to current technology.
Well,
at
here,
some
let
point,
me finish answering your question. The reason I bring up the monkey thing is because the computer is basically the monkeys mashing on the keyboards.
Right.
But then you also have a test in there. So you have the actual script of Shakespeare. And so you're constantly looking and be like, okay, this one's way off. It doesn't even have numbers, letters in it. It's just only numbers. Okay, that monkey take it out back and make a hamburger out of it. But this monkey,
implausible burgers.
But this monkey likes to use the space bar. And so even though it's kind of getting there and they're not really words yet, at least they kind of are structured like words. So that monkey, let's give it a monkey wife and see how many monkey babies it can put out.
Right.
And that's basically what the computer is doing. Is it's just this random mush, but you have an end goal. And when something kind of is close to that, you go, okay, let's do more of that, but let's continue mutating it a little bit. That gave me another result that's even closer. Let's mutate that a little bit more. Oh, yeah, it can be another result that's a little bit closer. Let's mutate that a little bit more. And you're basically going through generations. It's almost like evolution in a way.
Yeah, that makes sense. But I think the main thing that is hard to get your head wrapped around, though, is the stuff that happens in between there, because it's such a, like the colorization thing, for example. I mean, realistically, let's say you are tasked with colorizing an image. You have a black and white image. A human approaches it. Well, you have to isolate objects. You have to recognize what those objects are, and then you have to know what those real world colors of those objects are. And so I guess when you're programming machine learning to do that task, is that basically, I guess, the tasks you need to assign to it? Like, those are the skills it needs to have? You know, do you tell the algorithm ahead of time that those are the tasks it'll need for this job? And these you need basically object identification, like, or is that even part of the machine learning itself?
No, it's like you need to be a little bit specific and help the computer a little bit. You know, it's definitely not like here, I'm just going to give you every problem and you'll come up with every solution if I let you think about it long enough. Like, you definitely need to like give it some direction. But I mean, the thing that has me really excited about machine learning is that we have the potential here to perhaps internally develop plugins that can do rotoscoping automatically, or can do camera stabilization, or can do colorization, or even like highlight retention, or I'll bring highlights back in on low dynamic range footage. Like, all these are, like, you could theoretically make machine learning system where you give it a frame from a movie and it gives you back a lookup table that you can apply to any footage you want to make it look like the color grade from that movie.
Dude, I feel like we need to hire a programmer. Corridor R&D. And there's just a dude in like a closet just crunching.
So
like Niko 2, like crunching in the corner.
We should clone hard. Niko and then put him in a closet.
So actually last week I emailed Josh Davies over at FX Home. They make Hit Film and Ignite, which is a bunch of plugins and stuff like that.
Man, we're bombarding him.
Yeah, to ask him about if they want to try to develop some machine learning plugins, because there's already a rotoscope plugin out called Rotobot. But it's a little rough around the edges, and the guy is clearly like a one-man team. I'm not sure how much actual VFX work he's done. But some of these things just like in the hands of, I mean, I could go on, but I don't want to get into those specifics yet, because I feel like we're still kind of covering the broad topic of the magic that is machine learning still here.
I mean, I think you're getting into some interesting stuff, but my other thing was regarding these quote unquote neurons. At what point did computers start creating nodes of neurons and of code of their own?
I mean, theoretically, that was all possible since day one, but like, in the early days of computers, you could maybe have like 5 neurons and then you could balance them out. But obviously you need more of that web to like have anything complex. It wasn't until GPUs really became prevalent and powerful, because GPUs are made to basically just do as many calculations as possible. It wasn't until then that we could actually just be like, okay, here's 1 million neurons. Let's see what we get out of this complex web of just like weights and balances. Because like, in life, when you are making a judgment call, you're weighing and balancing different things, right? And the complexity of how much you can weigh and balance and run things through situations reflects kind of how sophisticated your final answer is. So it's kind of a similar thing with computers when you're doing, you know, AI development and machine learning. The more neurons you can make and the more sophisticated the layers in your machine learning network are, you know, the more sophisticated your answer can be. You know, it takes memory, computer memory, to store a picture. So doing a 64 by 64 pixel picture versus a, you know, 1080p picture, like that's a big memory difference. And when you have a million nodes that need to run a million pictures, you know, there's only so high of a resolution you can get with something like that. So
that's fascinating.
Yeah,
I understand ultimately both like at the same time why people would be so afraid of machine learning and also so interested in and desiring of it, because it's almost like it will become its own life form in a way.
Yeah.
Jake, you want to know something creepy?
What?
There's a documentary on some AI stuff. I forget the name of it, but at one point they had a little robot.
Yeah.
Then it was teaching itself how to do, you know, basic stuff that they told it to focus on.
Yeah.
And when they checked on it, a day, 2 week later, whatever, it developed a facial recognition ability that they never told it to do.
Right.
So it's just like popping off all these like.
So we just real quick, and you can go back to the actual practicality of this, but just thought, you know, you kind of need to approach this like a human being in a way, in the sense of I mean, say as machine learning evolves, because what you wouldn't do to a human being is say, well, human beings have propensity for the utmost evil, so we must lock them all up. You know?
No.
And you also wouldn't say, well, human beings have a propensity for the utmost good, so we must give them everything on Earth. I feel like, why would computers be any different?
Yeah, I mean, the thing is, everybody likes to think like, oh, AI, it's going to become super intelligent and just become another, you know, sentient organism. And it's like, well, no, you're anthropomorphizing AI.
Right.
Like everything is its own thing, and there's parallels and there's similarities. But like AI is effectively pure optimization, right? It's the quickest way to achieve an answer or the truth of something as the AI sees it.
Because it can calculate way more than we can.
Yeah, but I think,
once.
Jake, I think I understand your example, but you know, the problem is that we're still hypothesizing on like the speed at which it would learn. So imagine you have a child, he just got born, and you're like, cool, he's a child. And then, you know, day 1, he can't walk. Day 2, he's crawling around, and you're like, oh, well, I better put up these fences. And then day 3, he's 20 years old and living in a cage. Because, and so now suddenly the problem is you've skipped all these steps of things you're supposed to teach it. And I think that's what people are concerned about, is like the idea of like, all right, well, if it's so quick at learning, it could outpace the like things, the safety nets we put in place for it, depending on the stages it's at. And so
humanity outpaced
and so it's like, well, how do you put in place things that like the constraints it needs to learn to not basically take over like a power grid or something
really
like
interesting. I've never thought about that.
Yeah,
because it's like it's going to be out of our control.
And so suddenly you've got this thing that's intelligent, and you've now taught it. Like you thought it was a lot more immature, so you put these artificial constraints on it, but it already subverts all that stuff.
Yeah,
because it gets too advanced. And so it's like, how do you control its development in a positive way?
Well, I think people's fears of AI is a little bit misplaced. It's not like AI is going to like come to the conclusion that human beings are the inefficient, wipe out human beings. Like that's not how it's going to go. I think what people don't really realize is AI is much more like, oh, the AI figured out what kind of videos you like to watch on YouTube perfectly. So now you are spending 12 hours a day watching YouTube videos, right? Which is kind of already a thing, by the way. That's the AI. Like people don't understand, but that's the actual machine learning thing here. It's like you spending 3 hours a day on YouTube. That's the AI stealing your time, you know, because it's been watching you and following you, and all the other thousands of people that watch the same thing you watch, that have the same taste as you do. It's been studying all of you, and now it's giving you, you know, the pure sugar stream right into your blood.
Exactly.
But that's
and as a note, though, that's why you should subscribe to the Corridor Cast if you're not subscribed for some bizarre reason. Because if you're not subscribed, then you might fall prey to this very problem that Niko is discussing. An algorithm bot is tricking you into watching this, but we know it was your decision.
Take the power away from
Here's the thing, though, is like what you're describing is what was it, Sam? Was it was the step before general intelligence. It
Well,
was
narrow intelligence.
narrow
technically.
intelligence. Yeah,
Yeah.
it's good at one thing, you know, no, narrow intelligence, like it's good at everything kind of. No, I'm sorry.
A
I'm getting
narrow
backwards.
intelligence is everything from Tesla's autopilot to Google's YouTube algorithm
Siri
That's where it's
or
at
to
now.
things like isolated tasks.
General
hence
intelligence is when it's good at something like things generally. It's good at all things generally.
It can adapt to finding new things to get good
I think
at.
it's less about being good at everything. It's about being able to solve any problem you throw at it, given enough time to figure it out.
Yes.
I think that's where
Do
we're
you
at
think
now.
it'll set goals and create a discipline to achieve those goals?
It doesn't.
I don't know.
Whoa. I mean, its whole life is goal
I
setting.
don't
and
think we're at general intelligence right now.
we're not there.
We're not. No.
We're at narrow
No.
intelligence though.
Yeah, absolutely.
The thing is, like, AI is not good at creating. It's good at learning. It's not good at creating. And that's the one thing that human beings and any living organism tend to really do well still. A great example is AI Dungeon. So if you haven't been to Node and seen our AI Dungeon videos, you go check them out. Gabe has been doing the illustrations for them. They're
They
hilarious.
are incredible, and especially checking
Dude.
out those videos after listening to this conversation, it's an amazing follow up.
Yes. So what
wonder-
they did for AI Dungeon is they trained an AI to guess the next word after a series of words. So for example, Sam, if I say the sky is blank, fill in the blank.
On fire.
No one would
Ooh.
ever say that.
Sam just did. Sam
give me
just
a
did.
non-prompted in the middle of this conversation. If I just be like, fill in the most likely word. The sky is blank.
Blue.
Okay, cool. Give me another one. The sky is blank.
Black.
Come on, not cloud.
Nighttime.
I mean,
Cloudy.
AI Dungeon's
Nighttime.
fantasy.
Filled with
These are
stars.
all valid answers in a fantasy story.
Sorry, I missed. I should have given you guys more context here. Fill in the most
Oh, see,
likely.
we're like the bots. We failed.
No, you got.
We're like machine
so
learners.
Blue got rewarded, but black and on fire
Well,
got.
what's night then? What's night? Tell me what night
You
is.
just compared it to your correct
Okay,
answer,
you're right.
and you're like, try again.
So specifically, what I'm trying to say here is, you know,
That's
if I were to
ground
tell
truth.
any one of you
Yeah,
to fill
what's
in
the
the
ground
blank,
truth?
fill in the blank with the most likely answer. The sky is blank, or the grass is blank.
Green.
Gray.
Green, long, dead, brown, on fire, you know, whatever. But you wouldn't say the grass is doggy. The grass is banana. Like you
Yeah,
wouldn't
you're
say
not going
that.
to throw in a
You're
random
not gonna throw in a random
adjective.
word. Now, if you give a computer and you're like, guess, and the computer's like, here's my dictionary of words, and it just throws out a random word, you know that's what's going to happen at first.
Bad computer.
Bad computer. So what they did is they took a computer and they had it, you know, they would feed it words and it would try to guess the next word. And they went through, I think it was like 17 million web pages. And the thing is, you have the ground truth right there. You have the actual word that's hidden from the computer, and you reveal afterwards, like, oh, how close were you? Oh, you got it right. Cool. Whatever you did to get it right, keep doing that. And they went through and they did that for 17 million. It might have been 7 million. Either way, it's a lot. And they did that until the computer was really good at basically just contextually guessing the next word in a series of words, which us as human beings are pretty good at because we've actually spent our entire lives learning the exact same thing.
Speaking.
Yeah, exactly.
Yeah.
So, you know, you can throw a sentence at somebody and they'll, you know, have a good guess of how to finish it. And even if they don't guess what it's supposed to finish like, at least it'll sound right. You know, you're not just going to throw in a nonsense word into there. And that's what this algorithm, this AI ended up being able to do, is being able to have sensical sentences, and not just word for word, but whole paragraphs or multiple paragraphs, because, you know, it was able to hold all that in its memory. Whereas in the past, it might only be able to hold a sentence or two. Now it can hold multiple paragraphs. Now, the people that made this got kind of worried because you basically have a content generator here that can just spit out web page after web page of just fluff bullshit for people to then put ads on and basically break the internet with, which is kind of already happening once again.
Wait, hold on. Explain that again. What do you mean?
Like, you can just be like, I want to have a website that just generates pages for clicks so I can get ad revenue. So I'm just going to have it literally make up web page after web page after web page of like just randomly generated content. But it'll all sound kind of like it was written by a human being. But then once you read a paragraph or two, you realize it's just this weird dreamlike nonsense, just like that's only aware of its own context and just runs on. And
Basically, making AI headlines with AI, content.
if I wrote like,
Whoa.
the new Tesla automobile is a car that you should be watching out for, and I just let the AI fill in the rest of the article. And it's not going to actually say anything like of the value.
It'll appear.
It'll appear like,
You'll start reading. You're like, okay, all right, where's this going? There's no information yet, and then you finish it, and you're like, that's nonsense.
yes, which is kind of how AI Dungeon works. And so AI Dungeon is a text-based choose your own adventure game. And the thing is, it's prompted with a paragraph that's already written. It's always the same paragraph, and the computer just starts generating contextual text after that. But you write your prompts, and what's actually happening is that's just being treated the same as all the rest of the the text as context. So if you write, I grab my big sword and I fight the dragon, the computer's like, well, contextually speaking, the next thing should probably be, so he fights the dragon and the fiery breath burns his skin. It's like, it's just going to guess like that contextually sounds right based on what you were typing and what I've already typed. The thing is, it's only trained off of all these short stories that people have written. So all these clever twists and turns, it's not the computer making that up. Those are just from all the stories. As it pulls out the little pieces here and there, those little twists and turns have been created by people. So
that's the input?
Yeah, so the computer is not coming up with cleverness. The computer is just regurgitating contextually correct sounding stuff. But the cool ideas, like the good prose and the funny twists and like, the character speaking in a certain way or having a cool name, those are the human beings that invented that. So in a way, like the AI is good at remixing, but it's not good at inventing. Machine learning is good at remixing, but it can't just invent something from nothing. That's up to the human beings. But we have 7 billion, almost 8 billion human beings on the planet, and we've been inventing stuff for years and years and years and years, and much of it is now digitized. So there's these vast oceans of just content that the AI can remix, and no one's aware of it.
Okay, 2 things. This whole thing about the web pages breaking the internet because of clicks is exactly a main reason why we need to diversify. I'm not saying get rid of, but we need to diversify away from the click-based economy.
Yes,
on the internet.
It's Google's fault.
Humanity needs to do that.
Yeah,
and I feel like
it's
will.
Google AdSense that has made the internet that you have today.
Well, it was a great model to start things.
Yeah, it was.
And to get the rest of the internet like monetized and to like create actual economic structures that are protected and consistent. But it's now we're seeing all these other problems that no one thought of at the time.
It's like, have you ever tried to read a news article, just like something that you need to search for?
Right.
These days, it is a mess. It is literally just some intern regurgitating an article that some other intern wrote, which is regurgitating an article that some other intern wrote, and they're all putting about 20 minutes of effort into it.
Yeah.
And it's going down the whole like thousands layers of deep.
So
like,
that's the
and they're
first
all on
thing
Adderall too.
We gotta diversify away from that. I think there's always going to be a fundamental like niche, or not even a niche, but a fundamental sector that click-based like content will
people just need to get tired of it.
Yeah, they'll get tired of it, but also you need to move away. You need to it needs to be monetized through other ways.
What do you mean click-based? You mean like getting revenue?
Click-based
revenue.
So Google search is basically founded on prioritizing search results by
you
who's
won't believe
clicking on
what Tom Hanks's child looks like.
So you're saying popular stuff gets more popular?
No, not just that, but popular. If you click on something that's directly tied to a fraction of a penny being paid for that click, and that's the economic system that basically Google and then followed by Facebook has been created on the internet. And I'm saying that is only one model for information on the internet, and a way to pay to create that information, right? Like to pay to create content, to pay to create news, so all these things that serve a fundamental human need: entertainment, good, accurate information, right? Like a place to like store documents and trade documents and exchange data, right? All of these things. There's different economies that you can attach to all these different services that the internet can do, all these different functions that it can do. But the
main issue is that from Google's perspective, it's neutral. So it's like the quality of the content isn't relative to how it's prioritizing stuff necessarily. Right. And I think that's only become a public discussion over like the last 2 years or so.
Yeah.
With all these things with how Google's now starting to like rate information at least and kind of get itself out there a little more. But yeah, that's basically the consequence of that.
Could I hit you guys with an out there concept, perhaps to wrap up the mission?
I want to feel like I'm flying through space.
Let's get out there. We've got 3 minutes left.
All right. So you guys know, the main steps in biology. You have cells. Cells make up systems, organs, if you will. Various organ systems make up an organism, which is generally a complex life form. Initially life forms are just cells. Cells would work together and kind of form these little organelles, or not organelles, but basically organs, and the organs function together to make a whole organism function. So you have liver cells, and you have heart cells, and they run the heart, and they run the liver. Each cell is in and of itself an individual life form.
In case you guys missed biology class, guys.
But
that was it.
Like, I am not one thing. I am actually millions of little individual living organisms all working together, and yet somehow have a singular consciousness, right?
But only Niko gets credit.
Yes.
Only Niko is that.
So, we go on one-wheel rides all the time, and we will go up to the top of mountains. And
You mean we and you and yourselves?
me and myself.
His organs.
No, me and like Clint and Jan and Ren and those guys.
In our cells too.
Yep, and everybody's cells. We go on one-wheel rides all the time.
Yeah.
And we're standing up there.
Give him a little ride.
They like the sunset.
All right, boys, here we go. Hold on tight. Woo! Yeah.
Yeah. If you ever feel alone, just know that you have an audience of millions.
Oh, man.
Anyways.
Yeah. Oh, that's
So
good.
we get up to the top of these mountains, and we're, usually we're sitting around looking at the city.
Sorry, you say we. But continue.
Sam's already flying through space, but we're gonna go
I'm
even
out there. It was a
further.
great, good ride, boy.
But you look at the highways, and it's like those are like veins and arteries, and you got the little side streets for like the capillaries and stuff like that, and you have the electric grid, which is like the not necessarily the same thing, but it's like the nerves, and you have like the communication grids, and basically from up high on top of a mountain, all of us individual people working together, looks like we're building a lichen or like a organic mold that lives on the ground, right? With veins and pathways, just like your body has, veins for transporting, your blood and your oxygen and stuff like that. And you have like waste routes, and you have, your communication, you have your structural things, that build up your body. This is all, individual cells working together. And you kind of abstract it. And like I said, this is an out there thought, but just roll with me on this. When you look at the city from the air, it's kind of like every person is just a cell working together to make these organs, and these organs then run the giant organism, and that giant organism is basically the city, or rather the entire infrastructure that we've connected together across the entire landmass of the planet.
So like Burbank's a lung, and like friggin' Pasadena is like a kidney.
I would say the cities are more like the organisms, but like the power plant in Burbank is like, the heart or whatever.
So how do you how do you sum this up? Where is
That's
this
not
going?
that abstract. That's
That's like the Matrix, man.
That's like kind of what's That's kind of what's happening.
Right. So maybe there's an argument that, a city is kind of like an organism, but at a different definition. But here's where I'm going with this. So eventually, organisms get complicated enough to start a thought process. Everything's working together to start a thought process. And arguably, we are starting that era now as they take computers and start turning them into AIs that can problem solve and think for themselves. And they're not going to think in the same way that you or I think. They think differently. But us as cells are finally building this organ that can finally have a central thought system. And eventually that thought system might be all the connected neural networks of different computers and, the different algorithms and AI that are all then running together to give this thing a consciousness. Because I could see in 100 years from now, an AI dictates what happens in the city. Oh, this is the most efficient route that you should drive to clean up the garbage. This is the most efficient thing that
I totally
you guys
agree,
should do
and
to
I
repair the
completely
streets.
welcome it. I totally agree, and I've thought about this. Now that I know where you've gone with this, I completely agree.
So
because I think the concept of an AI government is the coolest thing in the world. It will bring so much.
I don't want to live in your communist AI government.
It's not a communist AI government.
It's
like,
going to be.
No,
It can't be.
no, it will though. But imagine the fact,
Can't be.
No, just imagine a world where AI is smart enough and we rely on it enough to be able to take this weight off of humanity's shoulders of all this dumb political bickering
right.
and
Yeah,
and put this decision-making process into a truly intelligent, neutral third party.
This is all covered in the book.
You cannot remove though. I agree that would be great, and there's probably a function for that, as well as for the city trucks. But what you guys are leaving out here, and what I think often gets left out in all this conversation, is that like the entire infrastructure of our entire society, at least pretty much throughout the world, is built on people's sovereign individuality. Like if we all think about you're driving down the road, like, right? Maybe this will go away with autonomous cars, but it'll just manifest somewhere else, right? Like you are choosing to stay in the lane.
Yes.
Right. And you are choosing to like get up, and you're choosing to do the right thing, and you're choosing to do all these things. Like the entire fabric of civilization is built on that. And so I don't know if like it would be communist. I don't know how
like
we
you
got
have no
there,
choice to
but,
do
like,
this way or that. What if
but,
it's like I'm not going that
it's
way?
still going to embrace. What I'm saying
You
is
can
like
still
fundamentally
compare it to a
it's-
ground truth,
it'll
though.
Still
You don't
embrace,
imagine that.
It still needs to embrace
Jake-
like this ability of like an individual, like, doing something and not just being like, like
I have a
rolling
question
around
for
in a
you.
fucking puddle of your own spit.
But
and
imagine
sweat.
with an autonomous car, there's not going to be like a bitch mode. You can hit a button, it goes bitch mode, and then drives aggressively. You know what I mean? Like
no,
there's
yeah.
going like these like things don't. That's
Guys,
the
guys,
point.
guys,
That's
guys,
the point
guys,
of like the AI. You
Guys,
know?
guys, I definitely think we need to come back and have an AI government like debate. We should do another podcast, AI government, and like break that down. And
All right,
figure out
guys,
how that would
next.
go.
Wait,
on the-
wait. I have
wait.
to ask you a question, Jake.
Oh,
Do you know what the most? Do you know which biological trait is most associated with high functioning logical intelligence?
biological trait?
Or I guess it's not. It's kind of biological, but you
Erectile
know, something.
dysfunction?
It's related to life forms.
Or-
It has. If there's this one trait that's sophisticated in animals, it correlates the most with having also highly intelligent, high functioning logical reasoning in animals.
ADHD.
Probably like
Huge beers.
tools or something. I have no idea. The concept's a little abstract for me.
Social interaction.
Yes.
The more an animal
Yeah.
has complicated social interaction, the higher its logical reasoning abilities.
That's
Birds, the more logical birds have very complicated societal systems. Same with
Dolphins.
other animals. Yep. And same with human beings. And so even though you are a sovereign individual, Jake, you can't but help. It's in your nature. You have heavy societal pressure
of
and
course,
programming.
yeah. But I'm
deep
saying
within
that's
your DNA
part
code.
of being a sovereign individual. Is like understanding. You have to interact with people to understand
Yes.
like that's how you reach your full potential.
Everyone is a sovereign individual, but I think the instinctual pressures of society weigh upon us far more greatly than
do you
we have.
use
control.
Google Maps,
Guys,
or is
guys,
that
guys,
too
we need the
communist
AI
for
we
you?
just
government
took
debate.
the conversation is so threaded right now. Guys, come back next week. We're gonna be doing an AI government
Oh,
debate.
I get it. You're one of the guys who goes on YouTube and immediately clicks subscription before any videos load.
No, you guys have
I
made
know
a
you
bunch
are,
of you guys
because
have made a
that's
bunch of
why we
assumptions
value
about
our
me
subscribers.
from very little context. Our time is up. I'm sorry. You gotta join us next
This
week.
is a cliffhanger.
Consider
We have
subscribing.
unfinished business.
Guys,
Yeah,
we are
need to come back
decades
and
away
do this legit.
from a central organism that thinks for itself, and we are all just cells in that
I'm gonna put a
giant
robot
machine.
mask on for the next one
That's it. We're out.
and a helmet.
Consider subscribing.
That's really interesting how we talk about
Yeah, so yeah, great times.
stuff.
And next
Oh,
time I
good
can't wait to talk
conversation,
about
guys.
it.
This is the
Like,
podcast
yeah,
after hours
so,
podcast.
Yeah, this is really cool.
Corridor
guys, and I'm
after
really
hours.
glad-